Hi there. A very good afternoon. We are so sorry for the delay. Some technical glitch couldn't download what I had to teach. So I hope everybody is here. Yes, Bacha Pati, am I audible? Am I visible? Are you there? Okay, I can read Yash being there, One Desire being there. All right, please make sure you tell your friends that we are here live and all set to carry forward the chapter Isomerism. Very important chapter, very useful chapter. It has its application throughout the different functional groups that we shall be doing. And yes, we are meeting after 1 week. We last met last Tuesday and now I am here. Okay, so nonetheless, I told you about the after so long we are seeing each other. So I told you about that I shall not be available. But now, yes, thank you so much. I missed you too. And I hope GOC is fully clear now. GOC, जो अभी तक हमने 4 सेशन करे. So we have so far done 4 sessions together, children. 4 सेशंस साथ में करने का मतलब है कि रेजोनेंस एस्टेब्लिश हो चुका है, टीचिंग स्टाइल आपको समझ में आ चुका है, आपको ये पता चल चुका है कि हम जो पूरा का पूरा सिलेबस करने वाले हैं उसकी जान है जीओसी, आइसोमेरिज्म. इनके बिना नहीं होता है काम, राइट? What about ma'am practical organic chemistry? Don't worry about that. I'm soon going to come up with the plan for that also. What is agenda for today? Isomerism. How long will isomerism take? Isomerism का एक और सेशन मैं आपका लगाऊंगी जिसके अंदर हम जितना भी आज के बाद जो भी बच जाएगा, we will take everything that will be left in that particular session. So my agenda is to fully complete class 11th का isomerism. मेरे लेक्चर का ड्यूरेशन बिभू मुझे भी नहीं पता क्या होता है. मैं एक एजेंडा लेकर आती हूँ, जितने टाइम तक वो एजेंडा चलता है उतना ड्यूरेशन चलता है, बट इट हैज टू बी समवेयर ग्रेटर देन 1.5 hours to 2 hours, right? Okay. Now, are you ready for this one? I'm sure. Please make sure if you're liking the session, do hit the like button. That's very important for us to, to gauge whether we are able to resonate with you or not. That's very important for us. So this is a request. I don't like saying it all the time, but yes, make sure you be a part of. If you're liking it, please hit the like button. Otherwise, I'm not asking you to, right? This is the requisite that we are, asking you with full, what do I say? होता है ना कि बनता है यार, है ना, बनता है. तो please make sure you do. With that, I'm saying it for once and for all. जो silent दर्शक देख रहे हैं बिना chat में enter करे, please subscribe and enter the chat so that you interact, because a lot is waiting for you. A lot. So, without further ado, let's get started. So, isomerism is like playing with Rubik. You've seen this Rubik cube, right? It's like playing with this Rubik cube. I am sure all of you have played with it and some of you still do. And if you haven't, you still can. All right, it's an experience that you must take wherein you have to bring in. So everything is like one single intact system wherein faces can be changed such that हमारा एजेंडा होता है कि सारे कलर्स एक जैसे एक फेस पे रहे. बट या हाँ, it's tough to solve. The bigger it gets, harder it gets to solve it. But it's fun, right? It's way better than the current video games, for sure, right? Well, so how am I relating this to isomerism? बहुत ध्यान से सुनिएगा. It is important for you to understand कि हम एक टॉपिक जो कर रहे हैं वो कर क्यों रहे हैं. हम बात कर रहे हैं आइसोमेरिज्म की. क्या है? हमने कंपाउंड लिया. You understand spectroscopy? Spectroscopy is a technique by which I can find out the mass of any compound on this planet. which is called mass spectroscopy. It is a technique by which I can find out any element present in a compound. So you can use NMR spectroscopy, IR spectroscopy. So spectroscopy is a technique which helps us in understanding the core of what is in the compound. So what we understand when we look at spectroscopy is, भाई carbon same, दो compound लिए, दोनों के carbon same है, let's say, दोनों के hydrogen same है, let's say, but we saw that their behavior is altogether very different. उनका behavior बिल्कुल ही अलग था. हाँ, है ना? तो Chandrayaan 3 also had spectroscopy instruments because why? We wanted to check what is on the surface of the moon. बिल्कुल सही ऋषभ. That's beauty of learning out here कि हम चीजों को कैसे relate कर रहे हैं बाकी outside world से. क्योंकि ये आपके शायद काम इतना नहीं आए फ्यूचर में, लाइफ में, इंजीनियरिंग करते हुए, or when you're starting your own startup, or when you're becoming an entrepreneur yourself, or when you are in a good company, working for the company, then I'm sure what stays with you is the learning that we are gathering from being together, right? So here, my also request for you is study and relate it with the outside world. That's important. Now, having said that, हमें पता चला कार्बन सेम है, हाइड्रोजन सेम है, ऑक्सीजन सेम है, सब कुछ सेम है, बट उनकी फिजिकल प्रॉपर्टीज बहुत अलग है, उनकी केमिकल प्रॉपर्टीज अलग है, सब कुछ सेम है, उनका मास भी सेम है. हमारे पास दो कंपाउंड है, उनका सब सेम, बट जब हमने देखी फिजिकल प्रॉपर्टी, केमिकल प्रॉपर्टी बिल्कुल अलग. In fact, it can be understood like this कि मैंने एक कंपाउंड, सेम मॉलिक्यूलर मास, सेम मॉलिक्यूलर फॉर्मूला, everything is same, they look exactly same. अगर मैंने एक इंसान को दिया, it can cause blindness to that person. But वैसा ही looking compound with the same molecular formula, same number of atoms, same empirical formula, same vapor density, everything same. Same compound as it is, but just that might be उसका spatial arrangement कुछ अलग होगा, जो कि मैं बाद में polarimeter से ही देख सकती हूँ. देखने के बाद नहीं समझ में आ सकता. A little change, let's say something which was rotating the plane of the plane polarized light clockwise is rotating the plane of the plane polarized light anti-clockwise with the same two compounds. And that compound can be a medicine. So, same compound can act like a poison, or the same compound can act like a medicine. Same compound, everything same. Do you understand the relevance of understanding isomers? Isomers आपने पढ़ लिया. One can be used to help a woman deliver child. It can work as an anesthesia. But the same compound, if given to that woman, it can cause the child to be dead. Same compound. What is changing? A little change. A little change. Cisplatin is used for cancer, not transplatin. So knowing the isomers are very important. So what are isomers? I'm sure you've understood. It is the phenomena of existence of two or more compounds possessing the same molecular formula but different properties is known as isomerism. Such compounds are called isomers. So we need to study isomers. सब कुछ same लगता है इन दो compounds का. आपके पास दो कंपाउंड्स होंगे, आपसे पूछा जाएगा कि इनके बीच में क्या रिलेशन है. ये इनका कार्बन्स तो सेम है, इनके हाइड्रोजन्स तो सेम है, लेट्स से ऑक्सीजन्स भी सेम है, राइट? बट क्या डिफरेंस है? यू विल सी दैट. क्या डिफरेंस है? डिफरेंस होगा उनके अरेंजमेंट में, कैसे एक बॉन्ड बना है दो के बीच में, डिफरेंट वेज, एंड दैट्स व्हाट आवर एजेंडा इज. सो वी विल अंडरस्टैंड टू टाइप्स ऑफ आइसोमर्स. वन इज स्ट्रक्चरल आइसोमर, वन इज स्टीरियो आइसोमर्स. देयर इज ऑल्सो अ थर्ड काइंड विच इज कॉल्ड कॉन्फर्मेशनल आइसोमर्स. दो I am talking about conformational isomers right now because they also are isomers, but they're not true isomers. True isomers क्यों नहीं है वो? क्योंकि आप देखेंगे कि they can easily be converted from one form to another. You can't isolate them also. आप नहीं बता सकते अच्छा ये वाला isomer है और ये वाला isomer है. They cannot be interconverted into one another in the sense that you isolate them. So since they cannot be isolated, we say that they're not true isomers. And there are infinite number of conformers possible. So, where are we going to study conformational isomers? we will do this third kind, conformational isomers. When I do the chapter hydrocarbon with you. अच्छा मेरी writing इतनी बुरी नहीं है जितनी दिख रही है. There's some problem today with the PPT. Couldn't download it, so I am directly doing the slideshow and doing it with you. So change the size of the pen. I really want to, but I'm sorry, can't help it because I couldn't download the PPT for some reason. So this is already running on a slideshow mode in the raw format. तो इसके अंदर features ज़्यादा है नहीं. It's just this option. No more features. Sad, no? Yeah, can't do anything. So please, I hope you bear with it. I'm so sorry. Yeah. ठीक है? So मुझे खुद नहीं अच्छी लग रही है अपनी writing देखने में. Kind of don't like it, but I am sure it is visible. है ना? समझ में आ रहा है. तो ये हम कहाँ पढ़ने वाले हैं कॉन्फॉर्मेशनल आइसोमर्स? हम पढ़ेंगे हाइड्रोकार्बन्स के साथ ही. ओके. आज का एजेंडा क्या है? आज का एजेंडा है इसकी पूरी की पूरी दिस इन वन शॉट. ये आज हम करेंगे. इसका एजेंडा क्या है? ये कोशिश करेंगे आज हम इस पे स्टार्ट कर पाए, बट बिकॉज वी हैव अ लॉट टू डू एंड टॉटोमेरिज्म विल टेक सम टाइम. So hence this I am expecting that I might start today, but we will see. This will go on because this again is composed of geometrical and it is composed of optical. So geometrical and optical. Geometrical याद है ना cis trans वाली चीजें, and optical आपको याद होगा plane polarized light clockwise and anti-clockwise. So these I am going to do in the next session. Okay. So I hope this is clear. Now, what are structural isomers? Compounds having the same molecular formula but different structural formula. That is, they differ in the bonding sequence of their atoms. Now, bonding sequence of their atoms से क्या मतलब है? In what way bonding sequence can be different? Now, there are different ways in which bonding sequence can be different. For example, look at this. आपके पास 1, 2, 3, 4, 5, 6 कार्बन्स हैं जो कि एक लाइन में अटैच्ड हैं. या फिर you can have 6 carbons attached like this where the principal carbon chain is of 5 carbons and you have a methyl here on the second carbon, so it becomes 2-methyl pentane. So what is different? The principal chain itself is different. So you understand the meaning of bonding sequence of their atoms is different. There can be different ways in which there can be a difference in the bonding sequence. On that basis, we can have different types of structural isomers. But for stereoisomers, if I talk about isomers that have the same bonding sequence of atoms and groups, but differ from each other only the way their atoms are oriented in space. 3D में 3D isomer भी कह सकते हैं हम इसे, क्योंकि you need to think, look, analyze the compound in 3-dimensional. कैसे 3D में बैठा है? Okay? You can't analyze it in 2 dimensions. So when I say 3D, तो इस तरीके के cis and trans isomers are part of stereoisomers, right? चलो, now let's enter the realm of structural isomers. That is why we have stereo audio as well. हाँ, stereo से मतलब समझ में आ गया? ऋषभ क्या बात है यार? ये बढ़िया बात लग रही है मुझे, ऋषभ. जो रिलेट हो रहा है ना आसपास के माहौल से, ये दिस विन्स माई हार्ट. वेरी गुड. स्टीरियो मतलब समझ रहे हो? 3-dimensional. एकदम जुग 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 घूमती है पूरी गाड़ी ना स्टीरियो से आपके, राइट? चलो चलो चलो. हेलो फ्रेश गेमर्स, चिल प्लीज. मेंटेन सम फ्रेशनेस इन द चैट. डू नॉट मेक इट स्टेल बाय स्पैमिंग. चलिए, स्ट्रक्चरल आइसोमर्स डिफरेंट टाइप्स के हैं. ये सभी हमें आज करने हैं. चेन, पोजिशन, फंक्शनल, रिंग चेन, मेटा, टॉटो, ऑल ऑफ देम. सो chain, position, functional, ring chain, metamers, these are very important. So let's dive into them straight away. Let's start with the chain isomers. The compounds having the same molecular formula but different carbon skeleton, different number of carbon atoms in the main chain or the side chain or both. आपका जो मेन चेन है वही डिफरेंट हो जाएगा. ठीक है, जो पेरेंट चेन है वही डिफरेंट हो जाएगा. IUPAC nomenclature will really help you out in this. For example, if you do the IUPAC nomenclature of this, you know there are 4 carbons in the parent chain, so butane. But if you do the IUPAC nomenclature of this, we have 2-methyl propane. So do you understand what is different? The principal chain itself is different. How many years previous questions are enough for JEE mains? Tanu Malik, more you do better for you. 20 years to karna hi hai. Right? Chalo. So butane, when we talk about, you are understanding this and 2-methyl propane, the relation is what? What is the relation? Chain isomers. So all these are also chain isomers, pentane, 2-methyl butane, 2,2-dimethyl propane. The question that you might ask me is, ma'am, हमें कैसे पता चलेगा कितने chain isomers है? क्या कोई formula है? क्या कोई trick है? क्या कोई hack है? So let me tell you, there is no hack. You have to draw them. You have to do it by your own understanding. There is no trick at all. If any teacher is giving you a trick, that cannot hold true for any compound. If there is no trick any which ways, so do not try to cram all this stuff. This has to be done spontaneously. So I'm sure this is clear for pentane. Next is hexane. Hexane का भी जैसे इन दोनों के बीच में क्या relation है? इन दोनों के बीच में relation क्या है? Chain isomers. Chain is easy. Next one. Position isomers. So compounds having the same size of the main chain and side chain along with the same nature of functional group but differ in the position of the multiple bond functional group or substituent. So if you would see, हमारे पास जब हम IUPAC nomenclature कर रहे थे, position isomers की बात कर रहे थे, तो हमारे पास क्या बात आ रही है कि position chain है, this thing will remain same, the parent chain. But what is going to change? The position at which your functional group is. So while doing the IUPAC nomenclature, you will see that the 2 different compounds are varying with the numbers. कैसे vary करें? Number, but1ene and but2ene. है दोनों but और but. The parent chain is same. Right? Okay. So look at the example, but1ene and but2ene, the relation is position isomers. सिर्फ position change है, बाकी सब same है. Number of carbon same है, hydrogen same है, तो molecular formula same है, molecular formula same है, तो आपके molecular mass भी same हुए, molecular mass same है, तो आपके vapor density भी same हुआ, vapor density same है, तो आपकी जो empirical formula है वो भी same हुआ, empirical mass भी same हुआ, right? So you understand? There are so many things different, but they will have at least one difference in physical and chemical property, right? At least one difference. Like for example, this compound exists in only one form. This may exist in 2 forms because you would further see that there is cis and trans possible. हाँ, छोटू सा difference नहीं है, huge difference, ऋषभ. Why huge difference? Huh? Huge difference because their chemical properties are going to be different. One can be a poison, the other one can be medicine. So, छोटू सा difference सिर्फ marks के basis पे नहीं decide करते हैं, उसके काम के basis पे decide करते हैं. And the same molecular formula, same empirical formula, same molecular mass, same vapor density, 2 compounds absolutely looking same masses, but are creating huge difference in the life of a person because it can kill a person or make a person alive. So you understand, there is huge difference. Huge. Right? There can be difference in the physical properties like boiling point. There can be difference in the boiling नहीं physical properties will be same. For example, देख लो यहाँ पे अगर 2 chloro और 1 chloro की बात करें, दोनों का physical property different होगा, दोनों के boiling points different होंगे, melting points different होंगे, solubilities different होंगी. Same हो सकती है, हाँ हो सकती है, but it will have at least one difference in the physical, at least one difference in the physical or chemical property. At least एक different तो होगी ही, at least. More, there can be huge number as well, but at least one. Right? So I hope Yash, you got your answer. Now, if I talk about, अच्छा ये बहुत important है, बच्चा पार्टी अगर आपके पास इस तरीके के compounds हैं, for example, para hydroxyphenol. I'm calling it para hydroxyphenol, and ऑर्थो हाइड्रोक्सीफिनॉल, दो दे हैव देयर नेम्स ऑल्सो, जिसके बारे में मैं अभी बात नहीं करूंगी. विल कम टू इट व्हेन वी डू अल्कोहल, because we have a lot of names, common names that we have to remember. So these two, how are they related? When you have the only difference is in the position of the benzene. Ortho पे है, meta पे है, para पे है. The difference is they will be positional isomers. Okay? Now, tell me, name the isomerism shown by the following compounds. Rapid fire, bachcha party. If you are from NEET, I am attending separate sessions in the NEET channel as well, Aakash Baiju's NEET channel. But yes, this topic hai, because it is not very different for JEE and NEET, though stereo is very different for JEE and NEET, this is not very different. So if you wish to attend, you may. Okay, so Swarlipi is saying position, Yash is saying chain, Soumya is saying position, Manu Bhav is saying position. Only position is changing, right? Here cyanide is here and here cyanide is here. On the first carbon cyanide is and here second carbon, right? So only position is changing, so positional isomers, right? Everybody? है ना? Cyanide एक में पहले कार्बन पे, एक में दूसरे कार्बन पे है. बताइए. मुझे सेलिब्रेशन वाले स्माइलीज दिख रहे हैं जाते हुए. हाँ, सेलिब्रेटरी स्माइलीज. राइट. सो प्लीज मेक श्योर आप मेरे बिठाए हुए जो जाल है उसमें ना आए. प्लीज, carbon containing functional group will be a part of the parent chain. So here there are 4 carbons in the chain. So 1, 2, 3, 4, this will be butane nitrile. Right? Which I can simply write as butane nitrile. And this one is having 3 carbon parent chain, right? So you can see carbon chain numbering will start from here. Here carbon numbering will start from here. So we will have 2-methyl propane nitrile. So obviously, what is different? The parent chain is different altogether. If parent chain is different, then they will be called chain isomers. So please do not call it positional isomers. The moment you have a functional group which is carbon containing, then you have to be careful. The same logic will go for this also, bachcha party. If I write it like this, and the moment you see it, you feel, अच्छा CHO यहाँ पे पहले कार्बन पे है और यहाँ पे दूसरे कार्बन पे है, position isomers, bhai, obviously this will be wrong. Then you come back home, say, ma'am, silly mistake ho gaya. This is not a silly mistake, this is a blunder. And do not do blunders. है ना? Chalo, next one. What is the minimum number of carbon atoms required for alkanes to exhibit chain isomerism? चेन आइसोमर्स दिखाने के लिए कितने मिनिमम नंबर ऑफ कार्बन जरूरी है? इंटीजर टाइप क्वेश्चन. प्रिंस इज सेइंग 3. हाँ भाई शिवम, बिल्कुल कराऊंगी. यही तो मैंने बताया स्टार्टिंग में, क्या चीज मैं कब कराऊंगी ये मैं बता दिया है. कॉन्फर्मेशनल कब कराऊंगी, स्टीरियो कब कराऊंगी. स्टीरियो आज हो जाना चाहिए शुरू, नहीं हो पाता तो वी विल डू इट ऑन फ्राइडे. अच्छा, तो ये जनता जो 3 बता रही है, मुझे ये बताओ इसका चेन क्या ही बनाओगे भाई? ये कोई चेन थोड़ा होता है, ये तो स्टिल इट इज प्रोपेन ओनली, नो भाई, ऐसी गलती मत करिएगा। 3 में इट इज नॉट पॉसिबल। 1 2 3 4, 1 2 3 4, दिस इज पॉसिबल। So, how many carbons are required? 4. So, answer will be 4. Right? अरे यार रितेश, मेटामर कहां से आ गया अभी? चेन आइसोमर सवाल है ना, जितना वन स्टेप एट अ टाइम, यही प्रॉब्लम है। हम आगे का सोचते हैं, इतना ही सोचना है कि मैं आज पढ़ लूं। ये मत सोचो मैं पूरा 1 महीना पढ़ूंगा, सिर्फ मैं आज पढ़ूंगा फुल एफिशिएंसी से। ये आगे का जो करते हैं ना, उसकी वजह से क्या होता है, जो प्रेजेंट मोमेंट है वो लॉस्ट हो जाता है। लेट्स बी इन द प्रेजेंट मोमेंट। नेक्स्ट क्वेश्चन, व्हाट आर द मिनिमम नंबर ऑफ कार्बन एटम्स रिक्वायर्ड फॉर एल्कीन्स एंड एल्काइन्स टू एग्जिबिट पोजिशनल आइसोमेरिज्म? पोजिशनल पे सवाल है। आप एल्केन्स, एल्कीन्स, एल्काइन्स, मिथाइल को ही सब्स्टिट्यूएंट बना के बताना। तीनों के आंसर अलग हैं, प्लीज सोच के बताओ। अलग अलग आंसर है तीनों के। यू हेल्प मी क्रिएट ऑप्शंस। एल्केन, एल्कीन, एल्काइन। Please write fully. For alkanes, how many? For alkene, how many? And for alkyne, how many? It is an integer type question. You help me with the options. 6 for alkanes, Ritesh is saying, okay. 4 for alkene, Swarlipi is saying, okay. Alkane, I've got 4 as an option also. 3 and 3. One option is this. Alkyne also I'm getting option as 4. Okay. Any other thing? So how many of you go with A and how many of you go with B? Okay, there is another option coming up, 4, 4, 4. Ritesh is saying A, Yash is saying B. 6, 4, 4, that means option A. 4, 4, 5. Okay, this is option D coming up. Sunita, again, anxiety question. Let's not worry about that. Cutoff kitna jayega will certainly depend on the paper, right? We can't just predict it right before the paper. 3, 4, 4. Okay, another option coming up. 3, 4, 4. Okay, let's do it. Let's do it. हमारे पास एल्केन मतलब 1 2 3 4 5 पोजिशनल है ना, पोजिशनल। अब ये हमें मतलब 4 कार्बन ही चाहिए, बट मैं अगर यहां कर दूं तो दिस इज गोइंग टू स्टार्ट द नंबरिंग फ्रॉम हियर। यहां से नंबरिंग स्टार्ट हो जाएगी, समझ रहे हो? So 5 carbons cannot be your answer. 6 carbon can only be your answer. इससे छोटा तो हो ही नहीं सकता चेन। इससे छोटा क्या ही होगा? 1 2 3 4 क्या ही पोजिशनल आइसोमर्स चेंज करोगे? बट 6 हुआ तो yes, it can be at carbon 1, at carbon 2 or carbon 3. So 6 is correct for alkane, right? Okay. For alkene, position has to change. So it can be but 1-ene or it can be but 2-ene. I'm so sorry for the pen and I'm not able to erase also because I'm directly running it on Google Slides. So pardon me for that. Some technical glitch, couldn't download it, so you have to bear with me. And that is why I got late also today. Okay, because I wasn't able to download. Now, alkyne का भी same हो गया, यहाँ पे 3 और यहाँ पे 3 ही हो गया. So 6, 4, 4 becomes your answer. Make sure you make your concepts strong. Right? Chalo, next. Now let's enter the realm of functional isomers. Compounds having the same molecular formula but different functional groups. तो यहाँ पे functional group ही change हो गया. अभी तक क्या किया? पहला हमने किया chain isomers जहाँ पे parent chain ही different होंगी. दूसरा हमने किया positional isomers जहाँ पे position of the functional group different होंगी. तीसरा अब हम कर रहे हैं functional isomer जहाँ पे functional group ही different होंगे. Right? चलो. अगर मैं बात करूं C2H6O, सब कुछ सेम है, 2 कार्बन, 6 हाइड्रोजन्स, ऑक्सीजन, बट द फंक्शनल ग्रुप कैन बी अल्कोहल और इट कैन बी ईथर. Carbons are same, hydrogens are same, oxygens are same, but functional groups are altogether different. Similarly, if I talk about these two, let's say मेरे पास C2H4O2 है, then you can have an ester as well as a carboxylic acid. 2 different functional groups altogether, right? अगर मैं बात करूं, हाँ, this goes wrong. बच्चा पार्टी, this has to be absorbed very well. Even though बोलते हम अमीन है, 1 degree, 2 degree, 3 degree amines, how they are related to each other is they are functional isomers. But ma'am, तीनों ही अमीन है. How can they be functional isomers? So what are functional groups is जिनकी functionality अलग होती है, right? फंक्शनैलिटी अलग होने का मतलब क्या है? केमिकल प्रॉपर्टीज वो अलग अलग शो करते हैं. जब हम बात करेंगे डिफरेंट टाइप्स ऑफ अमीन्स की, तो आप देखेंगे 1 डिग्री, 2 डिग्री और 3 डिग्री अमीन्स का नेचर बहुत डिफरेंट है एक दूसरे से. इसलिए इनके बीच में जो रिलेशन है वो हम कहते हैं फंक्शनल आइसोमर्स. सो व्हाट इज द रिलेशन? दे आर गोइंग टू बी फंक्शनल आइसोमर्स, राइट? बट the moment I'm talking about, let's say, propanamine, and I'm writing like this. So let's say this is compound A. You understand? ये दिख रहा है ना, NH2 बनाया मैंने यहाँ पे on the second carbon. This is B. What is the relation between A and B? Both have NH2. NH2 मतलब R-NH2 is 1 degree amine. R2NH is 2 degree amine. R3N is a 3 degree amine. What is the relation between A and B? Position. Very good, Yash. Absolutely right. ठीक है? हाँ, डिग्री ऑफ अमीन में तो है, और जैसे डिग्री ऑफ अमीन चेंज हो रहा है, नहीं, डिग्री ऑफ अमीन तो सेम है, 1 डिग्री अमीन है, बट पोजिशन चेंज हो रहा है. सो पोजिशन चेंज हो रहा है मतलब पोजिशनल आइसोमर्स. यस प्रियांश, बट द degree, if it is changing from 1 degree amine, if it is becoming a 2 degree amine, then it becomes functional isomers. This is a 3 degree amine, functional isomers. Got that? Next one. अगर इस तरीके से aromatic alcohol है, देखो है ये भी functional group alcohol ही, but सीधा बेंजीन के साथ जुड़ा हुआ है. Behavior क्या है कि ये lone pair will be involved in resonance because you know there is conjugation here. Again, GOC is helping you here. There is a conjugation present, and since there is conjugation present, what will be the behavior of this oxygen's lone pair? It will be involved with the pi bonds of the benzene. ठीक है? Don the Great चले जाओ ना बेटा. Nobody is asking you to be here. So if you see, अगर आपके पास लोन पेयर है और वो इन्वॉल्व है डीलोकलाइजेशन में, तो उसका फंक्शनैलिटी डिफरेंट हो गया. प्लीज मेक श्योर, डू नॉट गिव इट एनी अदर नेम. हाउ आर the two going to be related? If you have an aromatic alcohol and if you have this kind of an alcohol जहाँ पे 2 single bonds है between the double bond and the lone pair, so there is no conjugation, so we can call it allycyclic or aliphatic, I should rather say aliphatic alcohol. So aliphatic alcohol and aromatic alcohol, how they are related, like only this much I am considering. So this becomes what? Functional isomers. Yeah, this goes wrong, hence please note the 2 different cases here. ये तो सबको पता ही है, आइसोनाइट्राइल एंड नाइट्राइल आर टू डिफरेंट फंक्शनल ग्रुप. CN है और NC है, तो देयर पर्सनालिटीज आर गोइंग टू बी कंप्लीटली डिफरेंट. दोनों का बिहेवियर इज गोइंग टू बी कंप्लीटली डिफरेंट. All right. Similarly, methyl isocyanide. Anybody has seen this thing? Railwaymen on Netflix. MIC. Everybody knows about MIC. Finally, they have made MIC quite famous, which is based on Bhopal gas tragedy. हाँ, बट मेरे को कुछ प्रमोशन का ये वाला पैसा मिल नहीं रहा है. जस्ट प्रमोटिंग फ्रॉम द केमिस्ट्री पर्सपेक्टिव. सो मिथाइल आइसोसाइनेट. So if I talk about CH3, CNO and CH3NCO, the difference is, so this is methyl isocyanide. The difference is what? The difference is they are both what? Functional isomers. Okay? So methyl isocyanate and methyl cyanate, how they can be related to each other? They can be related to each other in the context of, that's right, the functional isomerism. So make sure you remember differences between whatever we have done. Questions coming your way. Find the relation between the following compounds quickly. इन दोनों में क्या रिलेशन है? देखो आपके पास क्या है ये चेक कर लीजिएगा. जिस तरीके से अमीन्स का मैंने बताया कि अगर डिग्री ऑफ अमीन चेंज हो रहा है तो वो फंक्शनल आइसोमर्स बन रहे हैं. यहां पे डिग्री ऑफ अमाइड चेंज हो रहा है. इफ यू ऑब्जर्व हियर वी हैव अ CONH2, दिस इज अ 1 डिग्री अमाइड. हियर CONHR, so this is a 2 degree amide. What is the relation between 1 degree and 2 degree amide? They will be, like Saikiran said, like Yash said, they will be functional isomers. Right? Chalo. Now let's enter another one, ring chain. See, ring chain is a kind of a functional isomer only. अगर आपके पास option में ring chain specifically नहीं है और functional isomers लिखा हुआ है for two such compounds wherein one has a ring and other one has a double bond, what is changing? Their obviously functional groups are different, right? ठीक है. So ring chain isomers are also functional isomers. ऋषभ, आंसर मेरे लिए नहीं है ना, आंसर आपके अपने लिए है. ये भी रियलाइज करना जरूरी है. You're answering for yourself and feeling confident in yourself. If you're giving wrong, you know in your heart that I've done it wrong, even if teacher has not pointed it out. So let's become true to ourselves. That's important. Okay, now ring chain isomers are also functional isomers. Like I said, you have to read the option carefully. If the option doesn't have ring chain, but the this is given, you know, functional isomer is given, go with functional isomer. You have to use your own brain as per the question's need. तो अगर मैं साइक्लोप्रोपेन की बात करूं और prop1ene की बात करूं, दोनों में क्या रिलेशन है? Both are ring chain isomers, and ring chain isomer is a type of functional isomer. So you know it both now. Similarly, C3H4 propyne हो सकता है, cyclopropene हो सकता है. What is the relation? Ring chain isomers or functional isomers. Now we will enter the other important category here, metamers. Let's see what are metamers. See, metamers मतलब कि compounds having the same nature of functional group but different nature of alkyl groups along the polyvalent functional group. What is this polyvalent functional group now? Understand this thing that polyvalent functional group means अपने left और अपने right में वो अलग अलग. I'm specifically talking about bivalent because that's what is going to be most common for us, because we have to change alkyl chains on either side of our functional group. So we will see such functional groups which can attach different alkyl groups on left and right. For example, my alkyl group that I can attach on left and right towards O is this. So this becomes, like Priyanshu is saying, this becomes ether. So ether is one such group. Similarly, let's say if I put S here, S, so this becomes thioether, like Priyanshu is saying. If I keep it like this, N, H, R here and R dash here. क्या कौन सा है ये? थायो का स्पेलिंग ठीक कर लेना ऋषभ. NH. This is amine, but what amine? Will this NH2 show? Will this NH2 be a bifunctional, bivalent functional group? No, right? So like Priyansh is saying, and one of you said ketone. So ketone can be there, right? Right? So this is a 2-degree amine. What about if I have instead of this H, I can have R, right? And R is same. So it can also be 3-degree amine, but it cannot be 1-degree amine. 1-degree amine cannot be there. What about ROH? Can this ever show metamers? No. Why? Because again, 1-degree alcohol नहीं, alcohol लिख रही हो सीधा. I'm so sorry, this all looks very bad to me also, the writing which is coming up, but pardon me. Okay, if I talk about RSH, again that's also monovalent functional group. Ester, very well said. Ganesh, ester, I think many of you were saying already ester. What about anhydride R, C double bond O, O, C double bond O, R dash. What about these? So anhydride can also be there. Ester can also be there. Can acid be there? Carboxylic acid, RCOOH? No. Can RCHO and aldehyde be there? No. An aldehyde cannot be there as well. Okay? So I'm sure first thing is you've understood that there has to be a bivalent functional group, just like our bivalent Ravana here. Do you see Ravan ka beach wala face is remaining same, the side faces are changing. एक जगह कितने हैं? 1 2 3 और एक में है 4 और एक जगह है 5. दशानन, 10 faces. Ravana having 10 faces. So it can be 3 and 6 on one side. It can be 4 and 5 on one side. But this main face is remaining the same. Right? Main face is remaining the same. The side faces are changing. Okay? So उन्होंने बाइवेलेंट, अरे मैं ऋषभ, मैंने बोला आदि पुरुष की बात मेरे सामने मत करना प्लीज. लेट मी बी zipped here. Next. So polyvalent functional groups which show metamerism are, ये सब हम देख चुके हैं. All these are also there. In fact, amide, a 2-degree amide can also be there, right? Now let's see the some examples. Ethoxyethane हो गया या methoxypropane हो गया. So if you see 1 methyl here and 3 carbons here, here 2 and here 2. So of course the alkyl chains are varying on the either side of our functional group. The functional group is not changing, right? Chalo. Similarly, look at this NH. Your 2-degree amine is here. Your functional group is not changing. The side alkyl chains are only the thing which is changing. Similarly, if I take a ketone, the only side chains are changing, but the functional group is not changing. So now you be on your toes, rapid fire question, find the relationship between the following compounds. Quick. Ganesh, उसका मैं शुभारंभ जो करूंगी तब करूंगी जब हम बात करेंगे वेज और डैश, जब हम बात करेंगे 3D की. अभी 2D में काम चल रहा है, 2D ही देखो. Let's not take ourselves out of the present moment. Present moment, please. So Rakshita is saying position isomers, Yash is saying metamers, Rishabh is saying metamers. Metamers, Rakshita. Okay. Now you have changed your answer from position to metamers. Yash is saying functional isomer. Ganesh is saying functional isomer. Lakshmidhar is saying metamers. Chahat is saying something else only altogether, another world altogether. सो बच्चा पार्टी ये बताओ मुझे, एल्कीन और एल्काइन दो अलग अलग फंक्शनल ग्रुप्स नहीं होते क्या? वो एक फंक्शनल ग्रुप है. वन इज एल्कीन एंड वन इज एल्काइन. सो ऑब्वियसली दे आर टू डिफरेंट फंक्शनल ग्रुप्स. ऑब्वियसली दे आर फंक्शनल आइसोमर्स. हेलो प्लीज. मेटामर्स कहां से आ गया यार? पोजिशनल आइसोमर्स कहां से आ गया? ऑब्वियस है ये तो. Alkene and alkyne are two different functional groups. So functional isomers. But before you answer, make sure you check the number of carbons, number of hydrogens. They should be at least isomers. हम क्या करते हैं ना, हम इतना सारी चीजें पढ़ लेते हैं कि हम बेसिक्स भूल जाते हैं. कई बारी दोनों के बीच में रिलेशन है ही नहीं आइसोमर्स, बट हम फिर भी रिलेशन एस्टेब्लिश कर देते हैं. सो प्लीज बी केयरफुल. Next one. What is the relation here? Find the relation between the following compounds. Rishabh is saying positional isomers. Ganesh is saying positional isomers. Meme World is saying positional isomers. Positional isomer, positional, very good, very nice, superb. So all of you, thank you. Lakshmidhar, you just stopped me from, retracted. Okay, positional isomers still going on. भाई मैं गिर जाऊंगी यहाँ पे, कहीं गिर गई मैं यहाँ पे नीचे है तो प्लीज वेकअप कॉल दे देना यहाँ पे कि मैम गिर गई है हमारे आंसर सुनकर. ऐसे तूफानी आंसर्स हम दे रहे थे. ऐसे साइनाइड के साथ एग्जांपल दिया तो है कार्बन कंटेनिंग फंक्शनल ग्रुप. प्लीज you have to look at the carbon containing functional group and start the numbering from there. 1 2 3 4 1 2 3 4 5. One is a butanoic acid and one is a pentanoic acid. So one becomes 2-methyl butanoic acid, the other one becomes pentanoic acid. Please मैं गिर सकती हूँ यहाँ पे आपके आंसर सुन के. इतने सारे गलत आंसर. अभी तो ऐसा सवाल किया, थोड़ा सा आगे चलेगी भूल गए चेन. प्लीज डू नॉट डू सच क्वेश्चंस रॉन्ग. वी हैव डन. अब मैंने साइनाइड को चेंज कर दिया है COOH में. CHO के साथ भी मैंने एग्जाम्पल दिया था कि एल्डिहाइड के साथ भी आपको मैं इस तरीके से दूं तो दे विल नॉट बी पोजिशनल आइसोमर्स. दे अपीयर टू बी लाइक पोजिशनल आइसोमर्स. यू माइट गेट अ फील बट दे आर नॉट, बिकॉज यू आर स्टार्टिंग योर नंबरिंग फ्रॉम दैट कार्बन कंटेनिंग फंक्शनल ग्रुप. चैन तो खो गया ये आंसर सुनकर. प्लीज ये तो आना चाहिए ना. अब ये सेम सवाल में थोड़ा सा और ट्वीक कर दूंगी तो फिर आंसर दोबारा भूल जाओगे भाई. प्रेजेंस ऑफ माइंड. सो दिस बिकम्स चेन आइसोमर. नेक्स्ट वन. व्हाट अबाउट दिस? द रिलेशन बिटवीन दीज फॉलोइंग कंपाउंड्स. प्लीज गिव इट राइट. टेक योर टाइम बट गिव इट राइट. So XYZ is saying functional, Yash is saying functional, but XYZ has retracted the message. Okay, let's see. So we have only Yash for now. XYZ is saying ring chain isomer. Karthik is in some other world only for now. Lakshmidhar is giving functional. Nadeem is saying positional isomers. Functional. So please make sure when you have a cyclic and an acyclic system, then only you say ring chain. This is not a ring chain isomer, okay? Both are having rings only. But the degree, if you see here, it's a 3-degree amine. But if you see here, it's a 1-degree amine. So when the degree of amine is changing, you know that it has to be functional, right? So everybody who is saying functional is right. Any other answer will be wrong, please. Okay, next one. Find the relationship between the following compounds. Quickly, let's see. Let's see if you ace this one or not. Yash is saying metamers. Mohammed is saying chain. Mohammed Farhan has said chain. Lakshmi Dar is saying not isomers. Mohammed Farhan is still saying chain isomer. Thrice he has said chain isomers. 4 times he has said chain isomers. Meme World is saying metamers. Meta World I was about to say. Okay, Ganesh is saying not isomers. Again. Okay. ऑब्वियसली प्लीज मैं वही कह रही हूँ कि जितना आगे हम नॉलेज गेन करते रहते हैं ना, पुरानी नॉलेज को पीछे छोड़ देते हैं. बेसिक डेफिनेशन आइसोमर्स की नहीं छोड़नी है. दे आर द कंपाउंड्स विद द सेम मॉलिक्यूलर फॉर्मूला. देयर मॉलिक्यूलर फॉर्मूला नीड्स टू बी सेम. डोंट स्टार्ट कॉलिंग एनीथिंग एंड एवरीथिंग एज मेटामर और समथिंग एल्स. प्लीज काउंट. So if they have a difference in, if you count, here we have carbon 1, 2, 3, 4 carbons, 1, 2, 3, 3 carbons. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Here 1, 2, 3, 4, 5, 6 hydrogens. Here 2 oxygens, here also 2 oxygens. So if you see, they are just varying with CH2 unit. And if they vary with CH2 units, we will not call them anything else because their molecular formulas are different, but we can call them homologue because they are having difference of a CH2 unit. And if there is a difference of CH2 unit, what do we call them? Homologues, right? हाँ, homologous series याद आया, वही है ये. So अगर ऑप्शन में होमोलोग होगा तो आंसर होमोलोग हो गया, राइट? ओके, नेक्स्ट वन. सो नाउ वी विल एंटर टॉटोमर्स. अब इसके बाद और लेवल बढ़ता रहेगा. सो प्लीज मेक श्योर वॉट एवर वी आर डूइंग प्रायर टू दिस, यू कीप दैट इन योर माइंड. उसको नहीं भूलना है. चलिए, सो व्हेन यू लुक एट टॉटोमर्स, इट्स समथिंग लाइक दिस. It's an equilibrium. It's a kind of an equilibrium. So, phenomena by which a single compound exists in 2 or more readily interconvertible structures that differ in the relative positions of at least one atomic nucleus, generally hydrogen, isomers exhibiting tautomerism are called tautomers. So, क्या हो रहा है यहाँ पे? यहाँ पे ये हो रहा है कि आपके पास 2 इंटर कन्वर्टेबल फंक्शनल ग्रुप्स होंगे. सो यहाँ पे आपके पास 2 अलग अलग फंक्शनल ग्रुप्स है. तो मैम क्या हम इसे फंक्शनल आइसोमर्स बोल सकते हैं? तो आपके पास फंक्शनल ग्रुप्स आने वाले हैं. फॉर एग्जाम्पल, अगर जैसे कि आप कीटोइनॉल की बात कर रहे हैं, लेट्स से एक इस तरीके का फंक्शनल ग्रुप है और एक इस तरीके का फंक्शनल ग्रुप है. दोनों ही अलग अलग फंक्शनल ग्रुप है. एक कीटोन है, एक अल्कोहल है विद एन एल्कीन. So when you have such kind of two functional groups in equilibrium with each other, or which may establish an equilibrium without giving a separate energy from outside. You're not breaking any bond yourself. The solution is showing it all by itself. So, such systems where because of the movement of one proton, अपने आप जो अंदर एक प्रोटॉन है वो थोड़ा सा गेड़िया मारेगा. गेड़िया, you understand? It's a very famous word, गेड़ी. Huh? So it is going to roam around. So roam around in the molecules such that you are going to have two different functional isomers, but we are not going to call them functional isomers because it's by the movement of one hydrogen. And there are very specific kind of these compounds which can show tautomerism that we are going to talk about. So, Yash, you might ask, ma'am, is there hyperconjugation happening? You might ask, ma'am, is there resonance happening? We'll come to it whether what is happening, right? When I show it to you, you will automatically understand. So, let's see what is happening, but we must understand the first and the foremost thing that they are not going to be functional isomers. We will not call them functional isomers, though you're getting functional groups, because it's a specific type of an isomerism happening in such a way where there is a proton shift happening. How is it happening? अब उसको देखते हैं. देखो क्या बात करी हमने, tautomers exist in dynamic equilibrium with one another. So जैसे कि ये हाइड्रोजन घूम रहा है, देखो कभी Z के पास गया, कभी X के पास गया, इस हाइड्रोजन से कि घूमने को हम कहते हैं tautomers, but ये कहीं भी हो सकता है क्या? कहाँ पे होगा? What are the conditions? Let's see. देखो एक तो है दो टाइप की tautomerism जो आपको पता होनी चाहिए. First type of tautomerism that you must know is diode tautomerism. यहाँ पे दो न्यूक्लियस होंगे, उसके बीच में गेड़िया मारेगा हमारा हाइड्रोजन, कभी कार्बन पे कभी नाइट्रोजन पे, राइट? बट triode is a different one and it's elaborate. Diode is a very chill case. ठीक है? Diode is a very chill case जहाँ पे HCN and CNH, do you see यहाँ पे hydrogen is attached to carbon and here hydrogen is attached to nitrogen. Why are we calling it diode? Because the positioning is 1 and 2. Right? So if you observe this hydrogen, it's okay Rishabh, let's put filters in our own reading. Let's just avoid commenting everything, है ना? But I want all of you to pay full attention because tautomers is very important and expect at least one question in your JEE mains and at least one question in your JEE advanced. At least one question. Just from here, tautomers is the most important thing when we are talking about structural isomers. So don't worry about the spammers and stuff. Let's focus here. With me, everybody who wants to study, be with me. Whosoever is not here to study, let them do. Right? They have their own wits and understanding of how they want to, what they want to do in their life. So let them do what they want to do in their life. Right? Okay. Here, if you now see, this is very simple. Like I said, कि आपके पास HCN और HNC, ये वाला जो functional group है, ये आपका simple सा functional group है, which you need to remember, which you need to keep in mind. Simplest diode tautomerism should be in everybody's mind. But triode tautomerism is interesting and vast. इसको समझना है. Diode समझ में आ गया. दो कार्बन्स के, दो एटम्स, दो न्यूक्लियाई के बीच में हाइड्रोजन ट्रांसफर हो रहा है. Right? So, if we talk about CH3COH and CH2 double bond COHH, if you see what we have is keto and enol. Now, why is it happening? How is it happening? Let's understand the condition. Condition number 1, usually present in the compounds with the functional group. देखो, आपके पास carbonyl, imine, nitroso, nitro. For anybody who is in need, needs to worry about this one only. But everybody who is a JEE aspirant, which all of you are, look at this. This is what you need to master, all of them along with this, right? All four of them. So imine, enamine, we will see that also. Nitroso Se, we will see that also. And nitro Se, we will see that also. Okay? Let's see the other one. Presence of at least one hydrogen atom on the sp3 hybridized alpha carbon. अब आपकी जो कंडीशंस है वो शुरू हो गई है. पहली कंडीशन, एटलीस्ट वन हाइड्रोजन एटम ऑन द sp3 hybridized alpha carbon. क्यों है? Let's understand that. Look at this. हमारे पास COCH3 CH3 इस तरीके का एक कीटोन है. इस तरीके का अगर कीटोन है, everybody, let's just focus here. Let's not worry about anybody outside. This is very important, like I keep saying. ठीक है? So please be here. मैं बार बार बोल रही हूं sp3 hybridized carbon. When I'm saying sp3 hybridized carbon, why am I number one specifically talking about sp3 hybridized? Why not something like an sp2 hybridized carbon? Why not this? Why not only why only sp3 hybridized carbon? Why not sp2 or sp? This is question number one. So basically, more elaborate way of saying it is एसिडिक हाइड्रोजन होना मांगता है. मैंने क्या बोला? कौन मूव करेगा? मूव करेगा प्रोटॉन. प्रोटॉन क्या होता है? H+. कहां से मूव करेगा? आपको देखना है बगल वाला कार्बन. बगल वाला कार्बन के ऊपर हाइड्रोजन लगा है, चलो वो कार्बन कैसा होना चाहिए? sp3. हाइड्रोजन लगा है तो वो मूव कर सकता है. कर सकता है. कितना परसेंटेज देगा अगर मूव करेगा, ये एक और स्टोरी है जिस पे हम आएंगे. बट पहली बात क्या करने वाले हम डिस्कस, कि अगर मेरे पास एक कीटोन फॉर्म है और मैं अगर चाह रही हूं देखना कि टॉटोमेरिज्म एग्जिस्ट करेगा या नहीं, व्हाट वी चेक इज बगल वाला कार्बन. बगल वाले कार्बन अगर sp3 हाइब्रिडाइज्ड है और उस पर हाइड्रोजन लगा है, सो दैट कैन मूव. राइट? ओके. नाउ अब मेरे पास ये sp3 हाइब्रिडाइज्ड कार्बन है. ये हाइड्रोजन को मैं ऐसे बना लेती हूँ. सो लुक एट दिस बच्चा. ये वाला जो बॉन्ड है, दिस कैन कम हियर एंड दिस कैन गो हियर एंड यू विल गेट O minus and this hydrogen can attach to this O minus such that you will get enol. Right? Okay. So tautomerism is possible if alpha beta unsaturated carbonyl compounds contain a hydrogen at its sp3 hybridized gamma atom. अब देखो एक और चीज. मैंने आपको क्या बोला कि यहां पे sp की बात क्यों नहीं हो रही? बार बार sp3 हाइब्रिडाइज्ड कार्बन की बात क्यों हो रही है? देखो, अगर मैं इस हाइड्रोजन की बात करूं, ये हाइड्रोजन अगर लेट्स से किसी तरीके से हम निकाल कर यहां ले आए, राइट, एंड इसको यहां पे ले आए, राइट, so what will happen is a double bond will come here, a minus will come here, and what you will end up getting is a cumulene, and cumulene is a very unstable system. You understand that? Cumulene is highly unstable. So that cannot be formed. You need to have an acidic proton जो कि निकलना चाह रहा है. You get that? Which wants to remove. Now, what if I have some more space here like this? Now, obviously, look at this. यहां पे हमारे पास जहां पे हमारा कार्बोनाइल ग्रुप होगा उससे साथ वाला कार्बन कहलाएगा अल्फा. दिस इज अ ग्रुप ऑफ इंटरेस्ट. हम क्या बोलते हैं? GOI, ग्रुप ऑफ इंटरेस्ट. जो ग्रुप ऑफ इंटरेस्ट के बगल वाला कार्बन है, जब हम कार्बोकेटायन की बात कर रहे थे तो हमारा ये कार्बन विद द प्लस वाज द एलिमेंट ऑफ इंटरेस्ट. सो इट कैन बी एन एलिमेंट ऑफ इंटरेस्ट, ग्रुप ऑफ इंटरेस्ट, सिस्टम ऑफ इंटरेस्ट. जैसे जब हम एल्कीन्स की बात कर रहे थे, जब हम हाइपर कॉन्जुगेशन की बात कर रहे थे, तो दिस वाज माय सिस्टम ऑफ इंटरेस्ट. इसके अराउंड मैं कैलकुलेट करी थी, तो ये बिकेम अल्फा. This became alpha, this became alpha, this became alpha. You understand? So alpha is that particular carbon, alpha carbon is that particular carbon attached directly to this system of interest or group of interest or element of interest. So अल्फा, बीटा, गामा। अगर हम इनकी बात करें, आपको ये वाला हाइड्रोजन दिखेगा जो कि अवेलेबल हो सकता है. लेट्स सी इफ दे आर और नॉट. ओके, लुक एट दिस CH2 और H. ये मैं इस तरीके से अगर मूव करूं, दिस बॉन्ड विल मूव हियर, सो देयर इज अ कॉन्जुगेशन एस्टेब्लिश्ड, and since there is a conjugation, there can be sidewise overlaps. That means there can be a resonance in such a way in between that this bond can come here, this bond can come here. This can only happen if there is conjugation, and this bond can come here. So if you see single, this is going to come here, तो double bond यहाँ आएगा, यहाँ पे single, double, यहाँ पे minus आएगा. That means let me I'll sort this out. Let me just complete this thing. Okay, I'll sort what is going on here and the shit which is happening in children's mind. My heart goes out, my empathy goes out. It doesn't mean that, see, I know this is a way to grab attention. इतना ज़्यादा void होता है ना कई बारी हमारे अंदर. We are so full of different voids that we want to find out a single way that we can pester and become an attention seeker just because we are anonymous here. So my heart goes out, my empathy. I hope that in life you do something which will give you peace and stability, because that's what we learn in chemistry. Everything is about stability. So more stability for you guys, anybody who is spamming, because I do not want to just go there. I would have to move a bit. So I'm sure this thing is clear that it is not necessary that alpha carbon should have hydrogen. It can also be there that beta के बाद क्या आता है? गामा कार्बन पे हो. और नंबरिंग कैसे करते हैं? नंबरिंग हमेशा स्टार्ट होती है जिसके पास हाइड्रोजन जाएगा. So 1 will be given to oxygen, so 2 here, 3 here, and hence the triad system, you know, when we were doing CH3, CO, CH3 का example, so hydrogen goes from here to this. So from 1 to 3, do you see this is carbon 2. So this kind of system is called tautomerism, जहाँ पे गामा कार्बन से हाइड्रोजन जा सकता है, तो भी वो हम ट्रायड के अंदर ही पढ़ते हैं, अलग से हम कोई और तीसरा कोई नाम नहीं है, राइट? पहले देखा गया था सिर्फ ट्रायड टाइप ऑफ सिस्टम्स में, बट जब हमने आगे देखा तो वी कुड सी दैट इट इज अवेलेबल, इट कैन बी अवेलेबल एनीवेयर एल्स ऑल्सो, राइट? ओके, नाउ I'll come back to all of this. Let me see how much you've understood from the questions. ये बताओ मुझे पहले, right? I'll be back. Okay. So which among the following can exhibit tautomerism? So this is what I keep saying. Please do not forget what we have already done. हम जो ऑलरेडी पढ़ चुके वो नहीं भूलना है. अगर आप इसको देखो यहाँ पे हाइड्रोजन अवेलेबल है, बट अगर ये हाइड्रोजन मूव किया तो हमारे पास क्या कंपाउंड बनेगा, कुछ इस तरीके का. यू गेट दैट? एंड अगर इस तरीके का कंपाउंड बना तो ये क्या है, दिस इज अ ब्रिज्ड कार्बन. एंड ब्रिज्ड कार्बन पे sp2 हाइब्रिडाइजेशन देना पाप है, पाप. You can't do that. So please do not forget Brett's rule. You cannot forget Brett's rule. Whatever we have done previously, you have to keep that in mind and proceed. Right? So one cannot show tautomerism. Next, if you see this is a carbonyl carbon. And if you observe here, ये हाइड्रोजन है, यहाँ पे फिनाइल है. This is also bridged carbon position, not possible. But what about this? No hydrogen available. Second cannot show as well. What about this one? Here also this is a bridged head carbon का जुड़ा हुआ hydrogen, cannot show. But what about these hydrogens? Yes, they can. So only and only third becomes your answer. All right, next one. Which of the following compounds will undergo tautomerism? Will this show? Will this show? Mohammed is saying no. Yash is saying no. Chemistry lover is saying yes. No. All right. Solitude is saying yes. So do you understand? हमारे पास carbonyl system है. Again, no alpha hydrogen. What alpha hydrogen are we wanting? We are wanting that particular alpha hydrogen, or that particular hydrogen which is acidic. So not this, not this, not this. All these are sp2 hybridized. So no, it's a big no. Not at all. Next one, no. No acidic hydrogen. So no tautomerism possible here. But what about this? Again, please be careful. So Nadeem, you might feel that it's a yes कि अरे ठीक है, अल्फा तो पोजीशन ब्लॉक्ड है, बट बीटा और गामा, बीटा का तो हम देखते नहीं है. क्यों नहीं देखते? क्योंकि यहाँ पे क्यूम्यूलिन बनने के चांसेस होते हैं, एलीन बनने के चांसेस होते हैं, एंड एलीन्स आर नॉट स्टेबल. Anything that will happen in chemistry where stability is coming. If no stability is coming, no such hydrogen is going to move. But if we move this hydrogen, तो ये यहाँ पे आया, यहाँ पे डबल बॉन्ड होना चाहिए था ना, इस तरीके का सिस्टम will also not show. So you have to draw, in case you are confused whether it will or it will not, you have to draw it and understand. Brett's rule कहाँ से आ गया मोहम्मद? There is no such fused system. Only for fused system you can apply Brett's rule, not here. Right? Okay, what about this? Okay, so Rishabh is saying yes, Mohammed is saying yes, Solitude saying yes, Rakshita is saying yes, Lakshmidhar is saying yes, Yash yes, Deepak yes. Obviously, you see the CH3, so benzene will be untouched. This is acetophenone, absolutely right, Mohammed, and it's a big yes. Absolutely, it will happen. Right? Now, we have understood where it will happen and where not. Now, let's enter that where is tautomerism going to be major and where it is not going to be major. Right? Okay. So a form of tautomerism between a carbonyl compound containing alpha hydrogen and its enol form is right in front of you, which is the famous, the patent keto enol tautomerism. But now we'll enter into kahan pe kya stable hota hai. So you would see generally, okay, generally keto forms are most stable. Okay. But what is the reason why keto form is most stable? नहीं नहीं नहीं, सच में पेटेंट नहीं, मतलब कि सबसे ज्यादा फेमस कंपाउंड दैट यू सी फॉर टॉटोमेरिज्म इज कीटो इनॉल टॉटोमेरिज्म, है ना, सच में नहीं. सो कीटो फॉर्म व्हेन वी टॉक अबाउट CH डबल बॉन्ड O एंड CC, इनकी बॉन्ड एनर्जीज हम बनाए तो बहुत ज्यादा होती है एज कंपेयर टू इनॉल फॉर्म. सो दिस इज वन ऑफ द रीजन, right? Okay. So like I said, keto form is major most of the times. Most of the times it's keto form which is dominant. तो हमें कैसे पता चलेगा मैम कहाँ पे इनॉल फॉर्म डोमिनेट करेगा? So there are specific cases. जैसे यहाँ पे देखो 100% almost is keto form for this compound which is ethanol. Ethanol doesn't want to exist like this, right? So there are certain cases where you can figure out where enol will be very stable if there is some type of intramolecular hydrogen bonding coming up, or there is some stability, extra stability coming up because of the resonance, or I can say mesomeric effect or hyperconjugation. So let's understand with example. If you see this, okay, let's come to this one. Look at this. अगर आप इसका इनॉल फॉर्म देखो तो 76% है इनॉल फॉर्म. इसका मतलब क्या हुआ? लुक एट दिस हाइड्रोजन इज हाईली एसिडिक. याद है जब हम एसिडिक स्ट्रेंथ की बात कर रहे थे तो हमने एक्टिव मिथाइलिन ग्रुप की बात करी थी. दिस काइंड ऑफ अ सिस्टम इज एन एक्टिव मिथाइलिन ग्रुप, राइट? सो what is active methylene group? This CH2 sandwiched between two electron withdrawing groups is called active methylene group. So this hydrogen is highly acidic, and if it is acidic, why is it acidic? Because once this hydrogen leaves, you will get a carbon ion, and that carbon ion is going to be very stable because of the two electron withdrawing groups. It will be in resonance with two electron withdrawing groups, plus there will be a minus I effect from two sides. So why not this hydrogen going? It will be a CH2 minus, so it will just be stabilized from one side. Why not this one? For the same reason. But why this one only? Because it is stabilized from two sides. So this conjugate base is most stable, and weaker the conjugate base, stronger the acid. Right? Okay. So when we have this system, now again if I expand it, you can see there is intramolecular hydrogen bonding also possible here with a 6-membered ring. There is a 6-membered ring and there is an intramolecular hydrogen bonding. Look at this, which is going to making our enol system very stable. Right? Chalo. Enol form of cyclic 1,2 dicarbonyl compound is more stable than its keto form. Again, I'm sure cyclic 1,2 dicarbonyl system generally has to be stable, right? But the moment there is aromaticity coming up, there is stability coming up. Right? Chalo. स्टेबिलिटी ऑफ एल्कीन जितनी ज्यादा उतना ज्यादा इनॉल फॉर्म स्टेबल होगा. सो अगर आप यहाँ पे देखो तो इनॉल फॉर्म का देखो, मैं आपके सामने परसेंटेज भी लाई हूँ. यहाँ पे ज्यादा स्टेबल एल्कीन है तो आप देखो इसका सबसे ज्यादा परसेंटेज होगा. जितनी ज्यादा स्टेबल एल्कीन होती है उतना ज्यादा ऑफ कोर्स इनॉल कंटेंट बढ़ जाता है. राइट? नाउ यू टेल मी द आंसर फॉर दिस. ऑप्शन ए, इफ दिस इज कंपाउंड ए, दिस इज कंपाउंड बी, दिस इज सी, और ऑप्शन बी. Or any other option, you let me know. Okay, so based on their stabilities, you know that जितना ज़्यादा जो भी keto है वो सबसे ज़्यादा stable होना चाहिए. So keto form should be most stable. And if you see these two alkenes, B and C, this is a more stable alkene than this because it's a more substituted alkene, right? So since it is substituted alkene, it is going to be more stable, and hence this becomes the order A सबसे ज़्यादा, then B and then C, right? Now, always remember aromatic जहाँ पे भी आएगा, that they are going to have the highest enol content because of the aromaticity coming up. Then dicarbonyl compounds, right? Beta dicarbonyl compounds, and then alpha dicarbonyl compound, and then monocarbonyl. Monocarbonyl में keto form is going to be more stable. Okay, now another question for you. Let's see. Option A. If this is A, this is B, this is C. Option B. Option C. Option D. So, stabilities of enol form, इसका enol form कैसा होगा? Because of the intramolecular hydrogen bonding, सबसे ज़्यादा stable होगा B का, तो B becomes more stable. यहाँ पे because hydrogen है और यहाँ पे COCH3 है, so सबसे ज़्यादा B का है यहाँ पे as compared to this one, because जब हम बात करेंगे conjugate base की, right? तो A और B में compare करने में, in fact here actually pK values play a role, so you would have to check the pK as such, but when we check the pK we realize that B here is more, so there are more than one reasons here because both are actually active methylene compounds, right? C में नहीं होगा इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग, क्योंकि एक और बगल वाला हाइड्रोजन ऑक्सीजन, बगल वाला जो हाइड्रोजन है कहाँ, मतलब दिस कैन नॉट, how can you expect this to have extra stability, right? So basically BAC becomes your answer here, right? Chalo. So the other type of tautomers that I want you to be mindful about is imine and enamine and nitroso and oxime. So if you see यहाँ पे NO, this is our system जहाँ पे हाइड्रोजन जाएगा, तो ये वाला हाइड्रोजन कुछ इस तरीके से मूव कर सकते हैं हम कि ये यहाँ आया और ये वाला हाइड्रोजन यहाँ चला गया, like this CH3, CH2, CH double bond N, OH. So this is called oxime system, right? Epoxides are cyclic ethers which is not here anywhere. Epoxide आपको worry नहीं करना है ना? But ये nitroso propane और oxime, so nitroso group, this NO is a nitroso group बच्चा. And this NOH, C double bond NOH is an oxime group. Similarly, this double bond C double bond NR, this kind of a system is imine, and we have this kind of an NHR, which is, of course, you can see there is alkene and there is amine, so enamine, right? So there can also be nitro Se form, this can also be asked, so these three you need to keep in mind. Since we're already done with most of the questions, I will take up few more in the next one where I take nitro and Se. Right now, let me see how much you've understood, keeping every concept that we have done so far. Tell me the answer for this one. You give me the options. Option A, Mohammad Farhan is helping me with CAB. Option B, Rishabh is saying BAC. Mohammed is now again saying BAC only. Okay, changed your answer. Increasing order of percentage in all content. CBA. Another answer coming, CBA. So please, that's what I'm saying. As we go ahead, please do not forget the things that we have already covered up. We have already seen this kind of a system. This kind of a system is anti-aromatic, bacha. If it is anti-aromatic, how can you call it most stable? Highly unstable. So B should be most unstable out of everybody. Least stable. Right? Acha, ab out of A and B, if you see, we have understood B is least stable. अगर but यहाँ पे देखें तो एक ही ऐसा position है जहाँ पे alpha carbon है. So you can get this and you will also have a keto group like this. This is what you have. So if you have to compare C and A, you would see enol content की stability यहाँ पे ज़्यादा stable है या यहाँ पे ज़्यादा stable है. ये enol है. तो आप इसको देखो, double bond, single double, single double. So it's kind of a conjugation here. So A becomes stable as compared to C. Right? So this was an amazing question and I hope you got it. None of you have given it right. Anti-aromaticity, ये सारे concept को दिमाग में रखते हुए आपको answer करना है. ठीक है? So I hope now things are clear. Okay? So there might be a case scenario wherein more than one functional, more than one type of isomerism is available. So please remember the trick here. FMCP is the most common one that you will be applying, but if there is a ring chain, then ring chain gets the priority, and if there is tautomer, this is when you have more than one particular compound showing more than one functional, more than one isomers. So if more than one and single correct answer you have been asked, if it is a single correct answer and you have been given two different compounds and you have been asked कि भाई इन दोनों में क्या relation है, आपको लग रहा है position भी और chain भी है, दोनों लग रहे हैं, तो you will go with C gets higher priority, so you will say C. Right? चलो, अवतार ऐसे एंड में आके सिर्फ एंजाइटी क्वेश्चंस पूछकर कोई आंसर नहीं मिलेगा और एंजाइटी मिलेगी, है ना? इजी और स्कोरिंग चैप्टर्स बता दीजिए. ऑर्गेनिक में कभी कोई सेक्लूसिव, एक्सक्लूसिव, सेक्लूडेड कुछ होता है क्या स्कोरिंग चैप्टर? हर चीज एक फ्लो में है. इट इज लाइक अ लैंग्वेज, यू नो अल्फाबेट्स, देन यू विल नो वर्ड्स, एंड देन इफ यू नो वर्ड्स यू विल एंटर सेंटेंसेस. यू कैन डायरेक्टली स्टार्ट सेंटेंसेस. दैट विल बी क्रैमिंग, नॉट डूएबल. राइट? चलो, इसको अप्लाई करते हुए मुझे ये बताइए इनमें क्या रिलेशन है. फाइंड द रिलेशनशिप बिटवीन दीज फॉलोइंग कंपाउंड्स. लेट्स सी. थिंग्स शुड गो राइट एंड नॉट रॉन्ग. More than one you can feel might be there. बहुत सारे अलग अलग टाइप के आपको लग सकते हैं आइसोमर्स यहाँ पे पॉसिबल हैं, बट यू विल गो विद द रूल. देखो, रिंग चेन है नहीं यहाँ पे, टॉटोमर है नहीं यहाँ पे, सो आई एम राइटिंग FMCP. दिस इज द रूल दैट यू शुड रिमेंबर. याद रखना, अगर कभी भी रिंग चेन है तो सबसे ज्यादा प्रायोरिटी रिंग चेन को मिलेगी, टॉटोमर से तो टॉटोमर, बट वहां पे डिबेट आएगा नहीं, डिबेट आएगा FMCP में. तो आप देख लीजिए, यहाँ पे C डबल बॉन्ड O है और यहाँ पे एल्डिहाइड ग्रुप है, तो और चीजें अलग अलग लग सकती है, बट वी विल गो विद दिस ऑर्डर. And if it is a single correct, then you will say they are functional isomers. Got how to use a trick? Got that? भाई अवतार है किस लिए? इसी नए अवतार के लिए तो हम यहाँ पे आए हैं, और हर चीज को टैग करके छोड़ो, मैं पढ़ रही हूँ यहाँ पे, सो यू नीड नॉट टू टैग. मैम सारे टेस्ट प्रैक्टिकल वाले करवा दो, जल्दी करवाऊंगी मैं. आई विल डू अ मैराथन, आई एम planning that very soon, so don't worry about that. You are in safe hands, so chill, take a chill pill. I will certainly cover it very soon. जितना एग्जाम से पास करेंगे ना, उतना ज्यादा रिटेन्ड रहेगा यहाँ पे, बिकॉज वहां पे क्रैमिंग वाली चीजें ज्यादा है, राइट? सो डोंट वरी अबाउट दैट, उसकी चिंता मत करो बिल्कुल. सो विद दिस आई एम एंडिंग टुडेज सेशन. टॉटूमर्स हमने पूरा किया. नाइट्रो एसी टाइप के क्वेश्चन भी मैं और लेकर आऊंगी नेक्स्ट सेशन में, अलोंग विथ द स्टीरियो आइसोमेर. Okay, so there will be a mix of questions and there will be stereoisomerism. So next session is going to be dhamal dhamakedar with a lot of questions. So come prepared with whatever we have done today, and we will go in the sequence. Mohammed, हम पहले यहाँ पे एक बारी ये खत्म करें, इसके बाद मैं आपको पूरा एक schedule भी दे दूंगी very soon. So don't worry about that. चलो, एंजाइटी क्वेश्चंस बढ़ते हुए. ऋषभ, apparently that's the only way possible right now. सारा एक साथ full, I do not think so there is any such possibility as of now. So all set, all the very best, keep studying and stay in best of your spirits. Take a good care of yourself. Bye-bye.